Hey everybody, it's Mr. Mott. I just want to go over again how to do our lab report, our baking soda lab report. And so a great place to start is Mrs. Centeno's website or on our shared document where we've got the holler. So once you click where it says click here for Honors Bio, you go under lab reports then. And you're going to scroll down, and what we're going to do is that we're going to open up the holler down here. So I've already got it open. And so, but when you open this up, you'll open up the PDF of the holler. And the holler does a great job of organizing our lab report, and that's why it's called the holler. So we got our title of our lab report. Should be more than just saying baking soda lab. You want to describe it more in detail. Talk about how we heated it up, we broke it down, and what we're trying to accomplish a little bit. Should be a separate page. Under the purpose section, there's 4 main items. Starts out with the problem statement. Our problem statement is on the bottom of our lab report, the first page, and it says basically that we're going to be using stoichiometry to determine which of the 5 reactions we think occurred, and that's your problem statement when we decompose baking soda. The objectives are not only what we're going to be investigating, but what do we need to be able to do to investigate it. So we needed to be able to turn, and you can have these as bullet points, we needed to be able to change the word equations into symbols. We needed to be able to balance those equations. We needed to calculate the theoretical yields of the solid products. So that means, for instance, in reaction A, if you have 2 grams of baking soda, how many grams of NaOH, sodium hydroxide, would you make? So that's what we need to be able to do. And then the last thing, we're going to be able to compare our experimental mass to our theoretical masses. And those are your objectives. The background is listed in your lab. You can feel free to copy it word for word. If you can paraphrase it, put it in your own words, that's fine too. If you want to do any more research on baking soda or some of the other products that could be made, then that'd be great. You might be able to narrow down some of the reactions that you think could possibly have occurred if you look at some of the other products that could be made. So that's that. You also want to have your 5 reactions in symbol form. Those go into your background statement, okay, in your background section. So you're going to have your paragraph, and then you're going to have your 5 equations balanced and in symbol form, okay. Assumptions in this lab, one of the big assumptions that we're making is that all of our product did react. That's a big assumption. Our baking soda and the product that we made looked very similar, both white solids, and so we're assuming that all of it did react. We're also assuming that one of our 5 reactions did occur. That's in our background statement, but maybe it's possible that we heated up our baking soda, a reaction occurred, and then as we heated it more, another reaction occurred that we didn't expect. That's a possibility. So there's some big assumptions there. So, and one of the main things I think in this lab is that we really didn't identify the product. All we are going to try to assume is that the mass of our experimental amount is going to match one of our theoretical amounts. And with that in mind, that's how we're going to determine which reaction occurred. But we don't truly know the identity of the substance. We just know the masses match. Okay? In your hypothesis, we're going to have to keep it a little bit general. I think our independent variable was the temperature, and our dependent variable was the amount of product. And so based upon that, we're going to say that if temperature and the amount of product are related, then one of our theoretical amounts that we calculate will be similar to our experimental amount, and that's what we'll use to determine which reaction occurred. I don't think we can get any more specific than that in this case because we have limited background information. All right. Your procedure, okay, real straightforward. List the materials that you used in your lab. If you use Bunsen burners, that's going to be different than if you used a hot plate. So make a list of those. Show me a picture of what your lab looked like. Okay, so so you can just search under images for that. Your procedure is going to be step by step, numbered 1, 2, 3, 4. Each step that you did is numbered. And there's a copy of that in your packet as well. Should be pretty straightforward. Data tables. You want to have your data table that has like your mass of crucible, your mass of baking soda, all those masses, those 4 masses that you have from your lab. You want that in there, and then you also want the class data. Don't just attach the image. Okay, I want you to type it out and organize it. Okay. Data analysis. Okay, the graph. I think I showed you in class how to do the graph, but if you forgot and you just want to brush up on it, make sure you did it correctly. All right, head on over to YouTube. You can search RMHS Chem baking soda, and right over here we got the bar graph making the baking soda. One thing I want to caution you about is I'm not sure the masses are correct in here, but it does show you how to do that. Okay, so just double check your theoretical amounts and use those values when you make your bar graph. Okay. All right, so we got our bar graph. Sample calculation. So I want to see one calculation. I want to see one of your calculations where you figured out the theoretical amount of product made. Okay. The second thing I want to see is that how did you figure out the experimental amount of product? What 2 numbers did you subtract to figure out the amount of product that you made? So I want to see those 2 calculations. All right. Each of these can be worth 3 points each, basically, in your lab. So make sure we got that. Data summary. Okay. So what we do in the data summary, first paragraph says paragraph 1. Okay. Give me a real quick summary of what you did. 2 or 3 sentences max. Okay. You heated up baking soda for 10 minutes. We let it cool down. We waited before and after, and we're going to be comparing our experimental to our theoretical amounts. Okay. Okay. So that's basically what you're going to list there. Okay. Discuss the precision of your data. Okay. So precision is how tightly your data was kind of grouped. So what you can talk about is was your data similar to the class data, and was the class data very similar to each other? Okay. In your data summary, this is a great place to talk about precision and sort of consistency. You can talk about a range of data. What was the smallest amount of product compared to the biggest amount of product that was made? So I want a class average. I want a range of the class data. Okay. And sort of within there, you're going to be talking about patterns that you noticed. Were people getting similar numbers, or were they getting very different numbers in their data? Okay. The third paragraph is kind of where you talk about trends. And in this lab, this isn't, I wouldn't say there's many trends in data. Trends are when things are kind of going up or going down based on changing our independent variable. We didn't really change the temperature. We kind of kept our temperature the same for our trials. Okay. Now, in the fourth paragraph, this is where you would talk about, and since this would really be our third paragraph, you're going to talk about which reaction do you think occurred and why. So give me a sentence or 2 about that. It should be pretty quick. Okay. For your error analysis, okay, make it easy on yourself. Okay. Go back to Mrs. Centeno's website. All right. And you see where it says error analysis template. Let's open that bad boy up. What you should do, okay, you should make a box like this. Make a data table, identification of errors. Okay, this will really help you so that you don't forget to determine how your error affects the data specifically. This is a real common thing that's missed. Don't just tell me it's going to change it. I know that errors will change your results. Okay, tell me how. Okay, will that make it too big or too small? All right. Now, for the errors, go back to your assumptions. Your assumptions lead you into error. I assume that all of my product reacted. Okay, try to figure out, is that a systematic or a random error that could have occurred? If all your product did not decompose, would that make your amount of, so excuse me, if all your baking soda did not react and decompose, would the amount of product, would it be too big or too small based upon that? Okay, so you really got to think about it. And then you could talk about how we could reduce the error. I want at least 2 separate errors here. Okay, so make your life easy. Copy this down, this chart here. You're not going to include this stuff here. You're going to take it into consideration. You're only going to have the data table. Okay. All right. Awesome. Okay. Lastly, you've got your conclusion. Nearly everything in your conclusion is already done for you. Okay. You just got to go back to your lab report at the very top and copy and paste. There's only a few things that you need to really add to it. Okay. Look at this, paragraph 1. Restate the problem. Okay, go up to copy and paste with your problem. Restate your hypothesis. Okay, there we go. Restate the hypothesis. This is something that you're going to add that isn't somewhere before. You're going to accept or reject your hypothesis. Okay, based upon your results. Okay, go back to your data analysis and your background. Restate some of your data. Okay, I wouldn't necessarily copy and paste it. You can even condense it even further. Tell me what you were trying to do. Tell me what your results said, your experiment. Tell me what you thought happened. You are going to restate some actual observations, but not quite as in depth as before. Okay, so you are going to be looking back at your data analysis list for that. Okay. Here's where you talk about assumptions and errors. So assumptions and errors go hand in hand. All right, saying this was a possible error that could happen, and this is where I think I could fix it. Tell me if you think it's a good model or a bad model. Okay, so error analysis and assumptions go together. Kind of grab some information from your chart. This is an error that I thought I saw. This is how I think it would affect the data. Here's how I would fix it. Okay. Paragraph 5, now you're going to go beyond our lab. Okay. Discuss what you would do if you're given the opportunity for further scientific study of the similar concept. Okay. So tell me what else you could study from this. What else could we do? All right. Could we do this lab a different way? Could we do it with different chemicals? You know, could we change our independent variable slightly and have a new lab? Tell me how we would do that. Okay. So that's a lot to take in, but that's kind of what we're looking at. The big sections as far as like points. Okay, your conclusion is like 6 points out of your 50. You know, it's a big section, but most of it's done. Your error analysis is big. Give me at least 2 errors. Tell me how they are going to affect your data. Okay, your data analysis is big, and so is your graph and your calculations. This is the kind of the meat of your lab report. Okay. If you got any questions, please email me, and hope this video helped. Bye.